Assalamualaikum warahmatullahi wabarakatuh. Let me introduce myself. My name is Fathul Hakim Al-Falah. As usual, today I will elaborate what's my answer from the end of the semester test, which is a spring mass test, actually. Now I will share my whole screen to give you the coding screen. Now, I must stay conscious first, then I must know the intention of the second question. We're going to talk about the second question. The second question is, attack engineers have specified that if the suspension system bottoms out too many times, the component of the satellite could be damaged, which could cost hundreds of thousands of dollars to repair. Therefore, it is important to determine the proper shocks for the suspension system of STTS to avoid any damage to the satellite. Topograph and engineers have determined that the force of the shocks in the most severe terrain at the highest speed of the HMPMV trailering STT will attain can be modeled by the function of 200 sinus times 40 Newton, where the t is in the second, and assume that x function of 0 is equal to 0 and x extent function of 0 is 0 also. Now, for each shock, solve the associated non-homogeneous equation. This will become our first intention. Now, what is the initial thinking about the problem? The initial thinking about the problem, we know that we can attain the model by the function of f function t equals to 100 sin 40 Newton. Now, the second intention is find the maximum and the minimum displacement, then determine the best shock suspension, then we must compare between the homogeneous equation and the associated one. We plot it, and then we explain the effect of the transient solution on the satellite. Now, going to MATLAB. First, we must define the initial thinking about the problem and the idealization. The idealization itself is the formula that given in the question. Then we define the force function like usual. It's a t times 200 sinus 40. Then we define the ODE of the non-homogeneous case, which is the suspension system variable that I put that. You can put it anything you want. It's only the variable. Then the initial condition, where this velocity and the x and the y is all 0. Now, the time spent for the simulation, we make it 10 seconds, and the parameter of different shocks is 10 values of the xi and k is 10, 20, 20 and 30, 30 and 40. Now, we solve the length shocks, the plot of the length. Let's run it. So, the first figure actually answers the most, it seems like using iteration also. The first figure is the answer of the first question, question A. Which states is for each shock, solve the associated non-homogeneous equation and plot the solution. This the solution. As you can see, the best shocks is the shocks that have constant of 30 and k for 40 because it's have smaller amplitude. The yellow one. Now, going to find the maximum and the minimum displacement. Like I said, the maximum displacement is 5.93 and the minimum displacement is minus 4.97. Now, like the next question, determine the best shock for the suspension of the STTs and explain the decision from the perspective of the satellites. Because the best shock is the shocks number 3. Like I said, the smaller amplitude 1. Why the smaller amplitude 1? If the amplitude is small, the shock that perceived by the satellites will be less than the bigger amplitude 1. So it will become greater durability for it. The next question is recommended shock. Solve the association homogeneous equation. If we see this second figure, non-homogeneous and homogeneous solution, basically if we're using homogeneous solution, it will become linear on the x equals 0. Why? Because it was ideal. It's not actual. If we use non-homogeneous solution, it will become an actual solution. We better use the non-homogeneous, but to find the easier way to find the solution, we use the homogeneous solution. That's for my explanation and elaboration on the day 5 method to explain furthermore, to elaborate furthermore for the first question and the fifth steps, which is instruction. Thank you. Wassalamualaikum warahmatullahi wabarakatuh.